Welcome to the class of Object-Oriented Programming through Java. My name is Vivek. I work in the Computer Science Department in Mlritm, Dundigal. So let us dive deep into the inheritance concept in Java. What is inheritance? Inheritance is considered as one of the strongest pillars of the object-oriented programming for the Java programming language. Okay, so let us see how this is going to operate. So it's from code duplication to elegant design, how it is possible using inheritance. Let us see. So what is this inheritance? It's one of the cornerstones of object-oriented programming because it allows the creation of hierarchical classification. Okay, so a class that inherited is called a superclass, and a class that is going to inherit is called a subclass. So therefore, a subclass is a specialized version of superclass. It inherits all the members defined by the superclass and adds its own unique elements. Okay, so subclass is not everything about inheriting from the superclass. Along with inheriting from the superclass, subclass can also have its own methods and variables. So to inherit a class, you simply incorporate the definition of one class into another by using the extends keyword. So using the extends keyword, you can inherit from superclass to subclass all the methods. For example, let us see a skyscraper and a building class. Okay, so is a building. So is a relationship is defined by the inheritance. So inheritance allows the creation of hierarchical classifications, be defining a relationship between a general blueprint, which is also known as a superclass, and a specialized creation called subclass. Here a building is a superclass. Okay, a building can be anything, a simplex, duplex, triplex, or a skyscraper, anything it can be. So what are the basic methods that form a building? Okay, the basic functionalities that form a building are given in the building class. Let us see. Every building has a foundation and has walls. So depending on the number of stories you are going to build, that defines your building. But all the buildings starting from a simplex to a skyscraper, everything contains two major things. Those are foundation and walls. So these methods belong to the building. So every skyscraper is a building, obviously. So that is the relation, is a relation, is a building. That means that it is going to contain all the methods of the building class. Along with that, it is going to have its own methods like having an elevator and number of floors, which can be simply exquisite methods of this, exclusive methods of this skyscraper. Okay, so along with the foundation and walls, every skyscraper has this elevator and number of floors. So this is how inheritance helps in creating new classes that are going to inherit from a superclass, also add its own principles or behavior, anything. Okay, so let us understand the concept of inheritance more by taking an example. Okay, so here how this is a simple logic how we are going to extend. So here we are having class A that contains int I and j. So void show j, that is your method that is in class A. So class B extends A, that means we are having a class B. Okay, class A contains I comma j. Okay, and class B contains k. Okay, so when you use this show ij method void sum, so all these I, j and k are available for class B. Okay, class B along with its object that is k, it can also get the integers I and j from class A because class A is extended to class B. Okay, with this one word, the subclass B instantly gains access to all public members of its superclass A. Okay, so let us see an example, a challenge. Okay, so building a scalable loan system. We know obviously loans are given by the banks, right? So here we are tasked with developing a loan module for a financial application. The initial requirements are to create classes for three distinct loan types: housing loan, personal loan, and vehicle loan. So let us say for a financial institution, we are going to write a code to develop an application that is going to hand out loans for people. Okay, so this financial institution is going to give loans on three categories: housing loan, personal loan, and vehicle loan. Okay, so each of these classes is complex, requiring around 300 methods to handle its specific logic, rules, and data. So obviously, these loans are different. Personal loan is different, vehicle loan is different, and housing loan is different. Everything requires certain details which are not bothered by the other things. Okay, so let us say we are having around 300 methods for each loan. So that makes it 300, 300, and 300. So that means out of the three loans, we are having at least 900 methods. Okay, so without a strategy of code sharing, we implement each class separately. If we, without any link between these things, let us say we are operating both three things separately, then what happens? Personal loan has 300 methods. Okay, housing loan 300 and vehicle loan 300 methods. So a total of 900 methods were written. So after the introspection, if we are able to see, we can find out that at least 250 methods in each class are identical. That means they are going to access the same things like name of the customer, what is his primary location, what is his job, what is his salary, okay, what is his marital status, everything. Okay, what is his educational qualification? Such things are there which are going to be repeated in all the three things. Okay, they handle the common logic like customer verification, credit checks, and payment processing, which bank he is operating with, where he is going to pay, credit checks, how many loans he have taken previously and how he has repaid them, etc, etc. So this is classic case of code duplication. That means the same information we are writing three times. Okay, the same questions we are asking three times, so same methods we are using three times. Okay, so that gives you 900 total methods written, out of which 750 are redundant copies. Okay, they are reused again and again, same code is applied, and maintenance is high overhead. That means the program has to maintain 900 methods, out of which obviously more than 750 are asking the same questions. They are duplicate, redundant copies. Okay, so how to solve this problem? This problem is solved using the concept of inheritance. Okay, so better way, the principle of inheritance. So what are we doing with this inheritance? Inheritance is a mechanism in which a new class acquires the properties and methods of the existing class. It is a cornerstone of code reusability in object oriented programming. Okay, so here what we are doing, the important thing is code reusability. Please pay attention on this thing, code reusability, which is one of the greatest contributions of the success of object oriented programming, when we compare it to its counterpart, that is the procedure oriented programming, where this code reusability is not at all a chance. Okay, but in object oriented programming, we can use a code once written, we can use it as many times as possible. It is going to be needed in our program. Okay, so here, parent class, we are creating a parent class called loan for all the three kinds of loans. Okay, we are having a single parent class called loan, and in that loan class we are going to supply all the methods that are going to be needed by the remaining three classes, the housing, personal, and vehicle loan classes. Whatever be the classes that are mandatorily required by all the three classes, we are going to group them together and put them in another class called a loan class, and we call that loan class as a parent class. Okay, so let us say we have the amount, duration, application details, and calculate interest. These are the methods. Okay, so here the relationship, it models an easy relationship. For example, housing loan is a type of loan, personal loan is a type of loan, vehicle loan is a type of loan. That means they are going to have their own properties, along with the properties they are going to inherit from the parent class, which is loan. The primary goal is code reusability. Write common code once and reuse it across multiple specialized classes. Okay, the mechanism is implemented Java using the extends keyword. Okay, so you might get an doubt. Suppose we are having this calculate interest method is there, which we have embedded in the loan class. Okay, so this calculate interest is there. So how do we apply this calculate interest for vehicle loan, personal loan, and housing loan? Because the loan varies. Okay, so let us say for housing loan it is some 5.5%, for personal loan it is some 13%, and vehicle loan it is some 9%. Three are different, but we are having the calculate interest as the method that is in the loan class. Okay, so how we are going to do that is done through interfaces. If you remember the interfaces from the previous class, those gives you what to implement. Okay, based on the runtime, if you are using a housing loan, this interest is applied, personal loan this interest is applied, and vehicle loan this interest is applied. But the common thing on the three things is interest has to be applied. Okay, so that is the method why we are going to put it in the loan. Again, duration also differs. Obviously, personal loan will be having the least duration, vehicle loan next, and next will be the housing loan, which goes for more than 10 to 15 years also it is possible. Okay, so for such cases, we are what we are doing, we are defining these methods in the parent class, and using the runtime polymorphism as well as interfaces, we are executing them in the subclass. Instead of writing the total method again, we are just implementing those interfaces and we are going to run the program. Okay, so the loan system transformed by inheritance. What happened here? Exact common code, 250 common methods are moved into a single parent class. Extend and specialize the housing loan, personal loan, and vehicle classes. They automatically inherit the 250 common methods and only need to define their own 50 unique specific methods. So what happened here? 50 plus 50 plus 50, that is 150. Okay, and here the obviously the loan method, the parent class methods are 250, which constitutes your 400 methods. So this 400 is obviously less than the total 900 methods which we will be having when we are implementing the classes individually. Okay, so here obviously we are saving some 500 methods. 500 methods overhead is taken away from the JVM. Okay, that is the code reusability application of Java inheritance. So the result, 400 methods written, code duplication is eliminated. So we won't be duplicating any codes. We are just reusing them. We are not writing the same thing again and again. We are just using the instance or the reference. Okay, maintenance is simplified. A bug in common logic is fixed in one place, that is the loan class. Even though we are having, if the changes has to be made, if we make just in the loan class, they are automatically reflected in the these three classes. So this is the advantage of inheritance. So the mechanics. So what are that? Now that we know the solution to the problem, let us dive deep into what are the applications, then limitations. Okay, so not every method is 100% applicable. Okay, everything has its own drawbacks. Even the inheritance along with its abnormal usages is also having a little bit of flaws. So let us dig deeper into that and find out first the applications, then the limitations. Okay, so to master inheritance, we must understand how parent and child object interacts. Okay, how they are going to, is the child is going to get everything from the parent? No, some methods are chosen by parents not to be sent to the child. Okay, that facility is also available in the inheritance. Let us see, especially regarding which methods can be called. Let's export two simple classes. This is a parent class and this is the child class. In the class parent, we are having public void m1. Okay, here we are having public void m2. So here child class, child is extending the parent. Okay, so what are the fundamental rules of method access, what they can access and what they cannot? So for example, here we are having the parent class. In the parent class we are having m1, and in the child class we are having m2. Okay, so let us see how the objects are instantiated or referenced using this. Okay, first one, parent reference, parent object. Okay, so here parent p is equal to new parent is defined. P dot m1 is valid because m1 is the method from the parent class, whereas p dot m2 is not valid. Why? Because child is inheriting from parent. Parent has no idea whatever the things present in the child. So here C is aware of M1, okay, whereas P is not aware of M2. So here when you create a parent object, okay, when you create a parent object, you are going to instantiate only the parent methods. You cannot instantiate or refer the child methods. That is case number 1. Now, case number 2, child reference child object. So here child C is equal to new child we are giving. So what is child here? Class child extends parent. That means C is able to access M1 and C is able to access M2 because M1 is inherited into M2. So C dot M1 is validated because it is inherited, and C dot M2 is obviously validated because M2 is present in the child class. Okay, a child reference knows about its own methods and the public methods if it is parent of its parent. Okay, now here parent reference child object. Another example, parent P is equal to new child. P dot M1 valid, obviously method M1 belongs to P. P dot M2 again compilation error. The reference type parent indicates which symbol are callable even if the object is child. So compilation error will be cannot find the symbol. Okay, so here what we are calling parent P is equal to new child. Okay, we are creating the new object called child. So P belongs to child, not parent. Okay, so when P belongs to child, what it can access? It can access M1, but it cannot find symbol M2 because it is an object of class parent, not child. Okay, object of parent but getting from the child. Okay, which results in the compilation error. Next one, child C is equal to new parent. This is also not possible. A child cannot create an object of the parent class. A child can create object of its own class only. So it is invalid compilation error, incompatible types. A child reference cannot hold a parents and not object. Okay, a child reference cannot hold a parent object. A parent is not a child. So using parent you can create a child object, but using child you cannot create a parent object. So these are the 4 fundamental rules which we have to remember while using the inheritance. So what are the types of inheritance we are going to have? Okay, the first one, which are supported in Java and not supported in Java. 2 classifications are here. Supported in Java. So what are supported in Java? A to B, single inheritance. That means B is going to inherit here class B extends class A. That is this. Okay. Next, multi-level inheritance. That means class B extends class A and class C extends class B. Okay. So multi-level inheritance, a class extends a child class forming a chain. Now let us see the beauty of this. Here let us say we are having a method A, here we are having a method B, and here we are having a method C. Okay, now if you can see here, what are the methods of a object instantiated by class B can access? Class B can access A and B. Okay, so this is class B. Class A can access only A because it is the parent. Class C can access both A, B and C. Now the beauty here is class C is able to access A and B because it is inheriting from B. Okay. Class B is able to access A because it is inheriting from A. But according to class C, it doesn't know that A is belonging to class A. Method A is belonging to class A. According to C, A is also a member function of class B. Okay. According to C, method A belongs to B, not A. That means here for C, the parent is only B. Okay. A parent, that means that in multi-level inheritance, a parent can also be child to another class. But the beauty here is that the child of the parent class doesn't know the parent of its parent class. Okay. So according to C, A belongs to B, not A. Okay. Because A and B are present in B, it is going to inherit A and B. That is your multi-level inheritance. Okay. Next, hierarchical inheritance we are having. What is hierarchical inheritance? A extends to B and C. That means multiple child classes extend a single parent class. That means parent can be single, child need not be single. Okay, so the other way around is not possible, where a child is single and multiple parent classes is not possible. That is also called multiple inheritance, which is not supported by Java. Okay, here A, B and C, this is not supported by Java. But next we have the hybrid inheritance, a combination of other forms typically involving hybrid multiple inheritance. So how this is going to do? These things are not supported in Java. If there is multiple, it is not supported. Okay. So why multiple inheritance is not supported? As we know that object-oriented programming is all about making life easy than the than the process-oriented programming, right? From that paradigm, we are program-oriented paradigm, we have shifted to object-oriented paradigm. Then why object-oriented paradigm? Java is not going to support multiple inheritance. What happens if multiple inheritance is supported? Let us see here. So the diamond problem, we call that problem typically as a diamond problem. So why Java is avoiding the multiple inheritance? Let us see with an example. Okay, so here there is a base class P1 and class P2, and class C is going to inherit from class P1 and class 2. Let us assume. Okay, it is not possible in Java. Let us assume that class C is going to inherit from class P1 and class P2. So what is the major problem here? Let us say class P1 is having a method M1. And let us say class P2 is also having a class called M1, a method called M1. So it is a Java rule that every class can have its own names of methods. Okay, so having class P1 is not a problem with M1 having in P2, because this method belongs to this class and this method belongs to this class. So as a C is the child class, it is going to inherit both M1 from class P1 and M1 from class P2. That means it is having two M1 methods, right? Now, when you create an object in class C, okay, and you create a method called, you are calling a method called c.m1. So which object it is going to call? Which method from which class it is going to call? That lies the problem here. See, when you create an object of class C and call c.m1, which implementation should be executed? The one from P1 or P2? The Java compiler has no way to resolve this ambiguity. So JVM will be in a fix. It doesn't know which object to call. Okay. To avoid this confusion and ensure predictability, Java's designer choose to forbid multiple inheritance for classes. So in order to turn around and get a method, they just simply ignored the multiple inheritance concept, because that is going to make the programming very complex. The last thing every programmer requires is making the program complex for the user. Programmer might be intelligent enough to understand what he is writing, but a programmer who is the user who is going to use it has to have the code in a simple manner to understand. So in order to avoid those complexity, the Java has simply prohibited using multiple inheritance in Java. So as I have started the class saying that inheritance is one of the cornerstone of object-oriented programming, let us see how it became the cornerstone. Okay, the rule is every class in Java, whether you write extends or not. So simply you are going to write some class C, and you start with public static void main string args. You are going to write and you are going to start. Okay, you think that you have started with class C. Okay, you are having nothing, but actually, without even writing the extends keyword, this class C is taken by the compiler as class object extends class C. Okay, so the object is the super class for parent class for every class you are going to define in Java. That means implicitly by default, every Java program runs on inheritance. Okay, so that is why inheritance is considered as a cornerstone or liver or heart, whatever you wish to call, but everything in Java runs through inheritance only, because everything that is required, the basic necessities that are required to run Java program are embedded in the object class, and this object class is implicitly, without writing any piece of code, is embedded for every class you are going to create in a Java program. That means JVM obviously calls for object class whenever you are going to compile a Java program, whether you write extends or not. Okay. So this is the ultimate example of multi-level inheritance in action, because whatever you are going to write, on the top of that object will be there. You can write some n number of hierarchies. Okay, you write a class A, B which extends A, C which extends A, D, E. Let us say you are having 5 classes that are going to extend each other. Okay, this is what you have written, but what you don't know is above all there is a class called object, and this A, B, C, D is inheriting from that object. Okay, so that is the power of inheritance in Java. Okay, why is this essential? The object class provides fundamental methods required by any Java object. As we have seen, that concept is called object oriented programming. That means whatever be the program you are going to write, you are going to write around an object. Okay, so whatever be the program you are going to start, you are going to start by first creating an object. Okay, and the very first object, in order to execute whatever be the basic necessities that are required, that are supplied through the object class. Got it? So object oriented programming means it has to run on an object. Okay, whether you create or not through your code, Java is going to create first an object by default when you start programming. Okay, for that object to run, for that object to constitute to your programming, it requires certain basic methods. Okay, and those methods are supplied to the object class. That is why the object class is implicitly extended to every program you are going to write in Java. Okay, they like such as equals, hash code, and toString, etc. All the things, basic things that are required, are inherited through the object class. Through inheritance, these behaviors are automatically available to every single object you create, demonstrating reusability on a massive scale. So code reusability is going to be started without writing a bit of code by you. Okay, you say that you have created a program, you have created an object, but before to that, another object is already created and properties are assigned to them. Okay, you are simply inheriting those properties to your box. So along with those inherited properties, you are going to give your own methods to the object you have created. Got it? So that is the power of inheritance. Inheritance is just like air in the atmosphere. It is present everywhere. Okay, you can feel it everywhere in the Java program. Next, what if a parent does not want to be inherited, does not want any children? What if a parent has a certain method that it does not want to inherit? Is that possible? The answer is yes. Okay, a parent can choose what methods are not to be inherited to the child class. Okay, and those methods are stopped by inheriting by using a keyword called final. Okay, so class A final void method is there. So when you declare this, okay, this class A may contain other public methods. Okay, and there is a class B that is going to extend class A. Okay, so let us say along with method, we are having some car, bike, etc. methods are there, which are public, not final. Okay, so this class B is going to get the car method, get the bike method, but it is not going to get the method, because method is declared as final. Okay, it is not going to inherit the final method. So that is how you stop a method from being inherited to the subclass. What if you don't want even the class to be inherited? What if I don't want any child classes? Then that is also possible by declaring your class as final. Okay, so final class A. Okay, that means it cannot be extended. You cannot extend that final class. Okay. Use final for security and design stability, ensuring critical parts of the blueprint remain unchanged. Okay. So that is how you use the final keyword. So let us once see the overall topics we have covered using the inheritance. What is the power of inheritance? The key principles of inheritance. First one, inheritance enables code reusability, a foundational principle of object-oriented programming, by modeling easier relationship with the extends keyword. The first thing you have to remember, extends keyword, and it is a easy relationship. And the second one is mastering the four rules of object interaction, that is child object and parent object. What a parent object can and cannot access, what a child object can and cannot access. Okay. Next, Java supports single, multi-level and hierarchical, and deliberately rejects the multiple inheritance because of the diamond problem ambiguity. Okay. The entire Java API is a testament of power of inheritance, with the object class serving as the universal ancestor. Universal parent class is your object class. Okay, providing core functionality to every object in the ecosystem. So if you are defining a class called shape that is going to have circle, square and triangle, that obviously means that shape is also inherited from object. Okay, so this is your inheritance. So let us meet with another topic in coming class. Thank you.